Hi everybody, this is a follow-up video to the build video of the BREmote version 2, and in this video we're going to have a look at, first of all, how to use the remote and all of the components, so basically a little bit like a user manual. Then the second step will be how to update the configuration of the TX and the RX module, and the third part will be how to update or upload new software or firmware to the remote and to the receiver in case new firmware should come out. As always, I will use the chapter option in YouTube, so you can at the bottom check all the chapters I have added and then quickly jump to the points that are interesting for you. So let's just have a quick overview. What we have right here is, of course, the remote that you just built. We have the receiver board right here, together with its small antenna. This will always come with the receiver if you buy the kit. We have the BEC board, so battery eliminator circuit, basically a 5-volt regulator. We have the external antenna for the receiver in case you ordered it, as well as the GPS module together with its antenna. Now I would say let's start with the remote and then quickly work our way through all the other parts. So for the remote, I already showed it a bit in the build video, but just to go over it again, we have 3 inputs. We have the on-off switch up here. We have the steering input in the back, and we have the trigger or throttle right here. On top of that, we have the display module, and in the bottom, and usually you don't need to take off the handle if you have a new version, we have this magnetic connector, and this is used together with a USB cable like this to charge and update firmware. On top of that, the remote also has Wi-Fi capability. At the moment, this is not implemented, but we could also use this, both Wi-Fi and Bluetooth actually, to update firmware or update configuration in the future. Okay, since we already have taken off the handle, let me show you how the USB charging works. So you just take this cable, attach it to here, the magnets hold it in place, and then with a 5-volt USB power source, you can see if we turn on the remote, it will show us this charging indication as well as the level of charge down here. So this will go up until it's full. You can see at the moment the battery is basically empty. What I would recommend is when you charge to turn off the remote again after you saw the screen and just let it charge. This way the charging will be a little bit faster. Overall, the charging on a very empty battery will take about 10 hours plus minus, and that will give you a few tens of hours of ride time on the water. One thing that can happen, for example, if there's dirt in your connector or if your USB power source is not big enough, when you turn the remote on, it will go immediately into this boot menu. That's how you know it's not charging properly. In this case, first of all, of course, check your 5-volt power source. And also what you can do is to just clean those contacts, especially if you've been in salt water or dirty water. They could be dirty, so just clean them, reseat the connector, and then once you plug in and turn on, you should see this charging indication again. Okay, so let's start with the remote. Now, once you turn on this remote for the very first time, it's going to want to do 2 things. First of all, it's going to want to calibrate all of the magnetic inputs. And secondly, it's going to want to connect to a receiver. Now, what we can prepare for this on receiver side is to just have it connected to a power source, like a 5-volt source. I'm going to use the USB-C connection. You could also use a BEC or a VESC to provide it power. And what we should always keep in mind is to have the antenna, even if it's only the small antenna, but always have an antenna connected to the receiver if you want to power it on. Now with this prepared, we're going to turn on the remote. One thing you're going to see is once we turn it on, it will first of all show us a boot. That means it's just booting up, measuring all its values. And that after that, it's going to show us VI, so voltage internal voltage of the battery, and then a number, for example, 3.5 volts. And that's just an indication for you how full is my battery. Now, this is just a normal lithium battery, so 3.5 is actually quite low. 3.8, 3.9 would be a medium, and then 4 to 4.2 volts would be basically fully charged. After that, it's going to show us EC, which means error in calibration. And then after that, off, which means hands off, don't touch anything. After that, an arrow flashing to the bottom, which means give it full throttle. And then after that, arrows to the left and the right, where we need to press left and right. Now, after we've done all of this, it's going to either show us EC, which means error in calibration, which I'm actually going to simulate by not pushing the trigger in the first try, or it's going to tell us save, which means everything was okay and the configuration has been saved. Now, if it shows us EC, it helps to actually connect the remote to USB, which I'm going to show you later, to a computer to see what actually was the problem. Okay, so let's start. Turn on the remote, you can see boot. Now you can see VI 3.5, so 3.5 volts. Now error calibration, hands off. Now it wants us to give full throttle, which I'm not going to do. Now it wants us to go left and go right. And you can see it shows us error again. Now, if we actually do this correctly, so here you can see again, boot, internal voltage, 3.5 volts, error, hands off. Now give it full throttle. Now steer it to the left. Now steer it to the right. And you can see now it says save, which means all good. I have saved this calibration to my memory. Now what you can see is it's saying EP, which means error in pairing. So it's not paired to a receiver. And it's flashing those two errors just to indicate once you want to start pairing, just press this to the left. On the receiver, we basically have two buttons. One is labeled bind and one is labeled aux. To put it into bind mode, we need to hold the bind button pressed while applying power. So I'm holding this pressed and now I'm connecting it to my power source. And you can see it turns on and this LED flashes very rapidly. If we wait too long, the receiver will actually on its own leave the pairing mode, and you can see that by this LED flashing very shortly, every like half a second. And that means the receiver is on, but it's also not bound to any device. Okay, so to bind the remote, again, hold the bind button pressed, plug in power, it should flash rapidly. And then on the remote in this EP mode, just push to the left, it says PA, and then it says save, and save means everything okay. And now you can see the remote has fully started up. What we also can see is on the bottom here, we get a good signal strength indicator. And also on the receiver, you can see we get a solid light, solid bind light, which means remote and receiver are connected. Now what you can see is by, for example, turning off the remote, it will flash like 50-50 on off. Yeah, so that's different to the short flashes when it's not bound. And this means it's bound, but it's not connected. It can't get connection. And then again, if we turn on the remote, you can see now it's solid red again. Also the other way around, if we unplug the receiver to simulate connection breaking, you can see also the remote will indicate a broken connection or no connection to the receiver with a flashing light right here. So now with this powered on, we are in the main menu of the remote. Now what we can do right here is we can unlock the remote by pushing to the left and then giving it throttle for a second. Now the remote is turned on. We can switch gears like this. And if we are in steering mode or if we have enabled steering mode, if we give it throttle, just a little bit of throttle, you can see we are no longer switching gears. Now we would be actually steering the craft. If you let go of the throttle, you can see we can still steer a bit. But if we wait for 5 seconds now, you can see it will leave the steering mode and go back to the gear switching mode. Now, one important thing, if we give it throttle and we steer, also steering will elongate this 5-second timer. So you can see I can steer basically infinitely long. It will not go back. I actually need to let go both of the trigger as well as of the steering, wait 5 seconds, and then I am back in the gear switching mode. Obviously, we can disable or enable some of those features in software, and we'll actually have a look at that later. But yeah, that's basically the basic way of using it. Now there are a few special modes which can be triggered by turning on the remote while holding the toggle or the steering as well as the trigger in special positions. So for example, if we turn the remote on and hold this to the left after boot, you can see it went back to calibration. So now it wants us to calibrate the remote. And in case you accidentally triggered it, don't worry, you can turn it off at any time. Yeah. And if we turn it on again, it didn't override the configuration. Yeah, it would only override the configuration if you go fully through the calibration menu. The second thing you can do is to pair. You push this to the right. Yeah, and now you can see it's in pairing mode. You can see it also lost connection to the receiver now. Now it wants you to pair the remote. But also again with this, as long as you didn't fully finish a pairing sequence, it's still with the old credentials to the old receiver. Yeah, so also if you entered this accidentally, just turn off the remote, turn it on again, and you're back with your old values. You didn't override anything. There are two other modes, and they are triggered with giving it full throttle and pushing to the left or to the right. And in this case, to the left means delete all configuration. So that could be helpful if you somehow screwed up the configuration and want to basically do a factory reset. And full throttle and to the right means it goes into USB mode. This is not really used at the moment. This probably will later be like a Wi-Fi or a Bluetooth mode. But then if we actually coded that, I will give you an update on that. Okay, so that's basically all you need to know about the transmitter, about the remote itself. Here you can see the whole receiver board. As I previously said, we have two buttons and two LEDs, and one is mainly intended for the bind or connection status, and one is auxiliary, so it could be used for, I don't know, GPS, logging, whatever. At the moment, it's not really used. At the bind LED, we already talked, so short impulse flashes means not bound to anything, like symmetrical on-off, so on-off for half a second each, means connected or bound but not connected at the moment, and then solid on means connected. Now again, also this board has some special modes on power on, so of course, as I showed before, if you hold the bind button and plug in power, it goes into bind mode, and if you hold both buttons and plug in power, it will also erase all configuration in the memory, and then lets you have a fresh start in case you mixed up some of the settings. Now regarding connections, of course right here we have the antenna connections, which you can either connect the small antenna or the big antenna to. Both of them work in the same way. They have this SMA connector, which you just screw on, and then that's it. For other connections on this side, we have the USB connector as well as 2 times those pin headers. And this is 2 UART ports. Now, what can you use UART for? Well, for example, for a GPS module, for communicating to a VESC speed controller, maybe some other things, but that's the 2 things that are implemented at the moment. What you can see here is that down here, you always have the voltage, so power supply basically. You have RX, TX, and ground. Now, since some VESCs, for example, communicate with 3.3 volts or some GPS with 5 volts, you have additionally to that on top, you can see right here, you have a voltage selection. So depending on if you put this jumper on this side, like that, now you would bridge the voltage to 3.3 volts. Now for a GPS module, for example, you need to bridge it to 5 volts because that's what most GPS modules use. For a VESC, for example, you would bridge it to 3.3 volts. And of course, there will be a detailed diagram on GitHub where you can see how to connect what and also where to set those jumpers. On the other side of the receiver, we have the outputs for ESC 0 and ESC 1. So basically motor 1, motor 2, or motor 1 and servo, or if you just have one motor, you always connect it to this side. And on top of that, you have inputs for BECs, so battery eliminator circuits. Now, if you use a VESC or other speed controller that has a built-in BEC, so built-in voltage regulator, you don't need to connect anything to those top parts. You just connect your 3-pin servo connector here and here, and it supplies power to the board and thereby generates all the signals. If you have an ESC, then usually they don't have a built-in battery eliminator circuit, and then you somehow need to supply 5 volts both to this side and to this side. and they should be disconnected from each other, so isolated from each other. You can do that by just purchasing 2 separate BECs. However, please make sure they are high quality, because some of the low quality ones generate like big voltage spikes on power up, and that will probably damage the electronics. If you want to be on the safe side, you can buy this battery eliminator circuit from us. You can see right here, this is where you just put in battery power, so between 18 and 75 volts. And then this brick will regulate 5 volts to the first ESC, and then this one will generate 5 volts to the second ESC. And both of them are fully isolated, so that means there's no connection between the input and any of the outputs, which makes it quite safe. One thing that you can see here is we have a ground bridge. So that just means on some systems, you may need to remove this in order to prevent a ground loop between the input and the output. However, for most systems, you can just leave this in place. And also that will be detailed in the GitHub page, how to connect everything. Now with those 2 boards, you can do one of 2 things. You can just put pin headers right here and maybe receptacles here, or just directly solder it. And you can see the boards will stack like this. And there are also some screw holes to connect them. Or if you want to have a little bit more streamlined flat profile, you can of course always just connect wires from here to here. So in this case, just connect ground to ground, 5 volt to 5 volt. And then also here, ground to ground, 5 volt to 5 volt. Don't like link or cross any of those. So this ground is different from this ground, so don't connect them. But yeah, basically like this, just connect this over here. And then you have a working system for any ESC that does not have a BEC. Okay, so that's basically all to say about this. Now again, GPS module is actually quite easy. We will have this antenna right here. It has a small UFL connector that you just need to connect to the main board. And then over here you can see again, we have ground, TX, RX, and VCC. And you connect them one-to-one to here. Yeah, so VCC connects to VCC, RX to RX, TX to TX, ground to ground. So just directly connected to this. Of course, you can put some wire in between, and then just with some 2.5 millimeter connector on the other side, basically plug it in right here, and now you have added GPS functionality to your receiver. So one last thing, if you have a VESC connected with UART, it will both read the battery voltage, so the voltage of your main eFoil battery, as well as the temperature through the UART. If you don't have that, you can still connect the battery voltage to this pin right here, where it says, let me turn around, where it says measure UBUT. And if you connect the voltage here and enable the feature in software, then you can still read out your battery voltage and show it on the remote. So with that, I think we have covered all important parts of the hardware. So now let's go to the computer, get our USB-C cable for the receiver, as well as our magnet connector for the remote ready, connected to the computer, and then let's continue there. Okay, so the best way to start on the computer is to actually go to the GitHub. So you can see here, this is the GitHub of the BREmote version 2. Make sure you're on the version 2 GitHub, not on the version 1. And then if you scroll down here, you can see some important links. So for example, the build video, the video you're watching right now, config tool, serial terminal expo tool. We will use all of them in a second, as well as the flash download tool, which we will use later. And also here's a little bit of explanation of the error codes. So for example, we already earlier saw the EP and the EC, which means not paired and not calibrated. And you can see there are some more error codes. Yeah, so if you have any of those, again, best thing to do is to connect the remote to the computer, open the serial terminal, read out the exact failure code, and then post this in the forum or send it to me to give you support. On the RX, we can also see this aux light can blink, and it means some specific errors. And here again, we can see the bind blink. We already saw that. Short periodic flash means not paired. Blink means paired but not connected. Solid means connected. And then also this can have some special blinking codes like double blink pause, 3 times blink pause, and so on. So you can see this right here. Also the inputs you can see, pushing to the left, calibrate, right, pair, USB mode, and delete, as well as if you push the bind and both buttons on the RX, which I just showed you a few minutes ago. Okay, down here I will add the connection examples. As you can see at the moment there's nothing here, and then here's a changelog. So let's start with configuring the TX first. And for that, again, we open the config tool, serial terminal, and export tool. You can see the config tool looks like this. We will quickly come to that, but before that, I will show you the serial terminal. Now, if you open this page, make sure you open it in Chrome or Brave or Edge. Basically anything except Firefox, because it doesn't work in Firefox. Now what we can do is, if we have connected the remote to the computer, we can click on connect up here, and it should show up in this window. At the moment, nothing shows up. So I'm just gonna double check if my connection to the computer is good, if the USB connector is properly on the remote. And then if we reload this page, now we can see, okay, USB serial, COM5, and then we click on connect. Now, at the moment, nothing will happen. So as a next step, I will turn on the remote. And after turning on the remote, you can see the remote starts up and gives you some output. Now, if this doesn't show up, make sure you're actually connected. Make sure the USB connection is there. Make sure the display of the remote shows something when you power it on. And if that doesn't help, please contact me and we'll try to find a solution. So you can see right here, when the remote starts up, it's telling you entering setup, and then gives you a short information about the remote. So we can see we are connected to the TX actually. We can see our MAC address. We can see a hardware identifier. So this means genuine. So open foil board version 1 with 868 megahertz hardware. So that's interesting. And something you can check if you're, for example, in the US and you get an 8M instead of a 9M, then probably somebody sent you the wrong board, or maybe you ordered the wrong board. Software version, this is just an identifier. For now, we have the software version 1. This way may go up to version 2, and just a compile date. Now you can see it goes through the startup. It gives us a configuration string right here, and I will talk about that a little bit more soon. And then it tells us everything okay, and it's checking if charging. Yeah, and at the moment it's charging. We can also see that on the display. Now the first thing we can do is put a question mark, exit CHG, so exit charge. And if we hit enter, you can see it says exit by user, starting radio. Yeah, now the remote is booting up, and now the remote is fully booted, and also on the display now we can see the lock symbol. That's the state we want to get the remote into. And now by sending a question mark, we can see all of the commands we can send it. Yeah, and at the moment we are interested in the configuration. So we'll put question mark conf. And then if we scroll up, it gives us again this general information. It gives us this config string, which we can already copy. Make sure you copy it from the beginning all the way to the end. And then just put copy here. And then it also gives us all the configuration in plain text, which may be interesting for later. Now, if you want to change that configuration, we go to this page that I've showed you before, this C-structure table page. Up here, we select if we are configuring the TX or the RX and which version. We already earlier saw it's version 1. So we select that. Now this field gets pre-filled with information. And then down here where it says enter base64 string 1, we put what we just copied. Yeah, so you can just put here, paste in here. And then once we did this, we click on process data. Okay, so if we click on process data, you can see this table down here gets filled with all of the configuration that the remote has at the moment. Now, some of those are basically just for your information. For example, version, you're not supposed to change that. Also, the calibration values down here, they are interesting. Yeah, so this is the raw magnet values you can see here, corresponding with throttle and toggle. Again, not really something we change, but interesting to see. Now, one thing that's interesting, and it starts right up here, is the radio preset and the RF power. So in a default remote, so basically freshly programmed, not configured, both of those values need to be changed, right? The first one is the radio preset. Now, if you're in EU, you change this to a 1. If you're in US, you need to change this to a 2, because that actually changes the frequency your remote operates on. and this needs to be according to the law in your country. You can see here the European version uses 868 megahertz. Now that's true for whole Europe. It's true for United Kingdom. The second version, as you can see here, is intended for United States and Australia, and it uses 915 megahertz. Now again, also this is true for most of South America as well. Just make sure if you're in a country that is not on this list or is not included in here to check which frequency you're allowed to operate on, and then select the correct preset here. The second thing we can see right here is the RF power, and as the name suggests, that's the power the remote sends with. By default, this value is at 0, and it can range from -10 to 22. I would recommend you to put it at 20, which in my testing is the optimum between battery runtime or energy consumption and range. Yeah, if you want more range, you could even go to 22. However, usually 20 is enough. If you only want to go short range, you can also decrease that to, for example, 10. Yeah, so this is a value in dBm. So basically emitted power in dBm. So again, I would recommend you for a long range build, so for a toboggy build, put this to 20. Okay, as already said, those values are not really interesting for us. Now down here, we have some values. So for example, the toggle dead zone, that's the dead zone in the middle of the toggle or in the middle of the steering, right? So because the steering will not always return to the perfect center, so there's a little dead zone, and if you find out that you want to have this bigger or smaller, you can change this value. There's a toggle difference. This is how much you need to push the toggle left and right until it's registered as an actual input to the user interface. So for example, if you're switching gears, how much do you need to push it until it's registered as a push? The toggle block time. This is how long the remote is in steering mode after giving it throttle or steering for the last time. So basically, how long do you need to wait until you can change gears again? Now, as you can see right here, this is in times 10 milliseconds. So 500 is actually 5 seconds. Then we have the trigger unlock time. Some of those are similar to what we had in the version 1 actually. So for example, this means you have 5 seconds after unlocking the remote to quickly give it throttle before it times out. Lock wait time the same. How long do you need to push until it locks? Gear change wait time, gear display time. All of this is basically just how fast the remote acts in the menu. Menu timeout as well. Error delete time. All of this just some timings. Now down here is some more interesting configuration. So for example, we have the no lock. Yeah. If you put this to 1, if you put this feature to 1, then the remote will not have this locking feature. It will always be ready to go. You will not have to unlock the remote, or you also can't lock the remote. No gear is also pretty obvious. If you put this to 1, you don't have the gears. You will always be at the highest gear. If you want gears, put this to 0. And then right here, you can see how many gears you want. By default, this is at 10 gears. You can put this to any value. I would not recommend more than 10 because then you just have to click a lot. But for example, you could put this to only 5 gears and then have a bit more coarser but easier to reach gears. You can set the start gear again. Also here, if you have 10 gears, let's say, then this gear needs to be set again between 0 and 10. The steering enabled just means, if the steering feature is enabled or not. Usually it's enabled. You can disable it. For example, if you have an e-foil that you don't want to steer. The throttle expo, this is an exponential curve. And for that, there's actually another web page, which I have also linked. And you can see by default, it says 50. That means you have a linear throttle curve. Now let's put it to the extremes. At 0, you can see you have this, basically upwards bent throttle curve. And that means even with low power, you already get, or with low input, you get a lot of output already. And you have fine control in the upper band. No, don't know many people that use that. What most people use is this way, which means that you have a lot of fine control in the first part of the throttle curve, and then only towards the end it will go up rapidly, so it will give you a lot of power. Now this can be used, for example, if you need a lot of power to start your e-foil, but then later want to have fine control. So that's a value you can basically experiment with on this page. And then let's say you found out you want the value 80. You just go over to this page and in the throttle expo put 80 right here, and then you're done. Actually in this field, sorry. You can see the next three fields, so the throttle expo 1, steering expo 1. Currently they are unused, as you can see by this tooltip, only the first one is used. They may be used later and are already included, but for now they don't do anything. As a next step, we have this calibration factor. So if you find out that somehow the calibration of the internal battery measurement is not working, you can change that here. But actually there should be no reason to change this value for you. Down here we can see actually the status if we are paired or not. We can see we are paired, and we can see our own address and the destination address. Now you don't, or compared to the version 1 of the BREmote where you had to invent those addresses on your own, on the new version this is actually automatically generated out of the MAC address and should therefore be unique. However, this could be used, for example, if you want to bind two remotes to the same receiver. Then you could use those fields, and if you want to do that, just write me a short message and I will explain how in detail. So now that we've made all of our changes in this configuration, we can click on this export button, and we can see down here it will generate a new base64 string. Now just to be sure, we can actually paste this in this string2 field and click on process data again. And then in the table, we get highlighted in red all the values that we changed. So you can see we changed the throttle expo from 50 to 80, and we changed the RF power from 0 to 20. Okay, now we want to save this to our remote. So again, if you clicked on export, you can either click on this copy button or you can just copy it like that. And now we go back to our serial terminal. Now we can quickly send it a question mark again to see all of our inputs. And now what we actually need to use is this input to write our base64 string to the flash memory. So what we do is we put a question mark setconf like this. Then after that we put a colon, so these two dots above each other. And then we put our configuration string like that. So make sure it's exactly like this, question mark setconf with a big C, colon, and then our configuration string. And with that, we can click send, and then the remote should tell us setting configuration, struct saved. Okay, with that done, we can do either question mark reboot to reboot the whole remote, like that. Or what we can also do is question mark apply conf, which I'm going to do in this case. Now you can see it's applied the configuration. And now what we can do is question mark conf again. And if we do that, we get the configuration in a human readable format. And as you can see right here, RF power is now at 20, just like we set it. Now, there are a few more interesting commands. For example, if you put a question mark print inputs like this, and you can see if I give it throttle now, the values change. So this may be interesting for debugging if you have problems with your magnets or whatever. Okay, so let's also have a quick look at the configuration of the receiver. Now basically it's the same as with the remote. You click on connect right here. You select the COM port. In my case it's COM3. And by the way, if you have multiple ports like this, easiest way to find out which one it is, just unplug the receiver again, see which one disappears, and then plug it in again and see which one appears again. Okay, so now if we connect, we can send it a question mark again, question mark conf, for example. And then we see the configuration. We see it's actually the RX we're talking to. That's good. And we can also copy this string. And then on this configuration page, select the RX, put it in here, process data. Now, here it's the same thing. We have the version, we have the radio preset, which is 1 for EU and 2 for US. We have the RF power, which in this case is -9. Again, we would put this to 20 for a long-range remote. Now we have the steering type, and if this is 0, it's for a single motor. If it's a 1, it's for a differential motor, and if it's 2, it's for a servo. So select that accordingly. You can see it's already selected to 2. The steering influence is basically how much the steering influences the motor speeds. So For example, for a differential motor, what happens is if you steer, that one motor gets slowed down and one motor gets sped up. And this value you can set between 0 and 100, and this just means how much the steering is influenced or how much the speed of the motors is influenced. Steering inverted is interesting. So if you steer to the right and your craft goes to the left, you can invert the steering with this value. 0 is not inverted, 1 is inverted. If your craft is not going perfectly straight, you can trim it by this value. And basically with that, if you put minus 10, let's say, it will steer a bit more to the left. And if you put plus 10, it will steer a bit more to the right. Now, those four values, PWM 0 and 1, this is the min and max for your outputs. As you can see, this receiver is already set up for a servo steering. So the first one is a usual motor output between 1500 and 2000. Now what we've seen is, for example, with the Flyer ESCs, that you need to set this to 1100 and this to 1900, for example. And then the second one you can see is set for a servo, so between 1000 and 2000. That's usual for a servo. Here you can set the failsafe time, so that means if we lose connection to the remote, how long should the motors keep going before shutting off? And this by default is set to 1 second. Right here, foil but low, foil but high. This is the voltage that is recognized as a low and a full battery. So let's say you want to set 20 volts or 20.5 volts, you just put it here. This would be the low voltage, and then 40.5 as high, for example. So you can just calculate this out of the battery you have and which voltage you want to be shown as empty and full. BMS detection, we've also had this on the version 1. You can connect the BMS to the receiver, to 2 dedicated pins on the receiver, and that will allow you to monitor this BMS, and if the BMS shuts off, it will give you an error. This by default is off. Wetness detection, the receiver also has a wetness sensor integrated, so you can just put like 2 wires or maybe a little PCB with 2 traces parallel to each other somewhere in your build. And if that gets wet, it can tell you an error. This, again, can be enabled, disabled. Data source, that means where do you get your battery voltage and temperature reading from. If you put this to 0, then it's off. If you put it to 1, then you use the analog measurement. And if you put it to 2, then you use the VESC UART input. GPS enable, also pretty obvious. If you put it to 1, the GPS will be red. And if you put it to 0, for example, if you don't have GPS connected, you put it to 0. The UBAT calibration, you can use this if this analog input, so if you select analog here, so let's say you put this to 1, if you read the voltage with the analog input and it's not accurate in your opinion, you can use this UBAT cal to calibrate it. And actually there's another tool for it. I will also link that, but basically what you can do is if you measured, or if the RX thinks it's measuring 15.0 volts, but you actually only put 14 volts in, then together with this calibration factor, if you put it here, you get a new calibration factor that you can upload to the remote to make the measurement more accurate. Okay, and then down here, same with the TX, you can see the information if you are paired and the address that you are paired to. Okay, so if you have then any differences or any changes here, you can click on export again, copy this code, and then put it in here. You can see all the values we've changed. Okay, now so to upload this, again, we say $set conf, and the configuration. And you can see it's been saved. Now on the RX, we can do a reboot. And you can see after the reboot, our configuration is applied and we can see all the changes we made here. Also on the RX, we have some interesting outputs. So for example, if you want to see the PWM it's putting out at the moment, you can put this, print PWM, and now you can see which values it's outputting at the moment. So this is interesting if you want to debug why your ESC is not working or which values your ESC is shutting off at. You can use this as well. So with that, we've covered all the important things, how to calibrate your RX and TX. So now in the next step of this video, let's see how we update the firmware in case we need to. Okay, so to update the firmware on the RX or the TX of the version 2, we need two things. We need the flash download tool, which we can download from here on the GitHub. And then if you open it, it will look like this. And we just have this executable file, as well as the software itself, which you can find under source. You can find this integration rx.eno.bin. Do not use the merged one. The merged one will overwrite the whole memory, and this one will just update the code while leaving all your configuration in place. So for RX and TX, download those files, and then let's start the flash download tool. Now, once we start this download tool, you can see the small window pop up, and right here, all we have to do is select the chip type, which is an ESP32C3. Then if we click OK, the actual tool will start. We can see it right here. And now we need to put some information right here. We will start by ticking this box. Now this line goes red. We click on the three dots here to select the software. And you can see right now I've selected the version 2 integration RX Eno bin. And then in the end here, we need to put a 0x10,000. That's the address we are writing to, so 0x10,000. That's everything we need to set up here. Now in the bottom right here, we need to select the COM port. And now for that, actually, it would be a good idea to make sure that we are actually connected to the receiver and that it's actually working. For that, we can use the serial terminal again, just connect to the correct COM port. Again, for me, I know it's COM3. Make sure that you're with the correct one. We're actually running something on here. And then on here, if we put a $conf, what we should be able to see is that we're actually connected or talking to the BREmote version 2 RX. Now we can click disconnect here. Remember the COM port we've been connected to, and select it down here. So in my case, COM3. And now once we've done all of this, we can click the start button. Now it will tell us sync. And then after that, it should go to download. Now it's going to download the new firmware, or actually upload the new firmware to the processor on our RX. Now, if it gets stuck at this point, that usually means you have a bad USB connection or you've selected the wrong COM port. So in this case, just try to select it again. Try to see if you can talk to it with the serial terminal. And then at some point right here, it should say finish. And now with that, all the software has been updated. And we can actually see if it worked. So we can click on connect again. We close this. We can connect again, connect to the COM port, and you can see right here, if we compare this, let's see. Yeah, so this was compiled May 8. And now on here, we have the new software compiled May 26. So we see the update has worked. What we can also see is if we check the configuration, that all the values we've set are still there. So this is everything I had set before. Now, if you want to make sure that you don't lose the configuration, what you of course can do is before doing the update, just copy this configuration string, save it somewhere on your computer, and then later apply it again in case your configuration went missing. But again, this shouldn't happen if you follow all the steps that I just showed you. Okay, software update on the TX works exactly the same. I'm not going to show that again. Just do the same things, connect it, make sure the TX is actually turned on, make sure you can talk to it with the serial terminal, and then just use the update tool or upload tool with all the settings I just showed you. Okay, with that, we are at the end of this quite long video, I think. So if you have any questions, leave them in the comments, and I wish you a nice time. Bye.